Good afternoon, class. Welcome to Chemistry Live class. Today we'll be considering atomic structure and bonding. I'm sure our day went well. Okay, so let's start off. What is matter? We all know that matter is anything that has mass and occupy space. Moving down, let's now talk about atom. Atom is the smallest particle that can partake in a chemical reaction. By the way, this is the periodic table chart and we'll be using it today. So atom is the smallest particle of an element that can partake in a chemical reaction. That means hydrogen. This is hydrogen, is an element, but it's also an atom. Two atoms then will give H2, and which is a molecule. But only one is an atom, right? And so this is atom of hydrogen. Atom is anything. Atom is smallest particle of an element that can take part in a chemical reaction. Now let's talk about ions. Ions. We are familiar with the words. That's an atom or group of atoms that possess electrical charge. Atom or group of atoms that possess electrical charge. So it can either be positive or negative. For atom, it will be neutral, right? But for ions, it either has positive charge or negatively charge. And I made mention that it's either an atom or group of atom. Example would be Cl minus. This is an element, chlorine, right? But it carries a charge. So this is chlorine ion. And also H plus. Hydrogen is an atom, right? But it has electrical charge, and so it is now an ion. I want to make mention that positively charged means cation, negatively charged means anion. So that means a positively charged ion is cation, a negatively charged ion is anion. And how are these forms? For cations, the atom in question will lose an electron. It will lose an electron in order to become positively charged. We know sodium is in group 1 on the periodic table and is number 11. So it has 11 electrons. Once it loses one, it becomes 10 electrons. And here it will be Na plus. And this has 10 electrons. Let's consider another element, magnesium. Magnesium is number 12 on the periodic table, right? If it loses one electron, it becomes magnesium plus. If it loses another electron, it becomes magnesium 2 plus. And it then moves from 12 to 11 to 10. Whereas for anion, they are negatively charged and they gain this by gaining electron. Anions gain electron. That means an atom will gain electrons in order to become an anion. Let's consider one group, 17 elements, which is chlorine. Chlorine is number 17 on the periodic table, right? And so when it loses one electron, it becomes, when it gains one electron, it becomes chlorine minus, and it will now be plus 1, and this is 18. Oxygen, the 8th element of the periodic table. When it gains one electron, it becomes oxygen minus, and this is 9 because it has gained one electron. And it then gains another electron, becomes oxygen 2 minus, and this is 10. So you gain electron to become anion, you lose electron to become cation. Moving on now, let's talk about molecules. Molecule is the smallest part of a substance that can exist on its own and take part in a chemical reaction. The smallest particle of a substance and can exist alone and still take part in a chemical reaction. Molecule can either be an element or a compound. It can either be an element or a compound. We know hydrogen is diatomic, right? And so it exists as this and not this because it's diatomic. And so this is a molecule of hydrogen. This is an atom of hydrogen. O3, this is ozone. This is a molecule of ozone, and it contains 3 atoms of oxygen. It contains 3 atoms of oxygen, but it is a molecule of ozone. And so molecules generally is the smallest part of a substance that can exist on its own and still take part in a chemical reaction. And I make mention that molecule can either be an element or a compound. Compound NaCl, H2O. This is a molecule of water. Yes, it contains 3 atoms, 2 hydrogen atoms and 1 oxygen atom. This one also contains 2 atoms, 1 sodium and 1 chlorine, but is 1 molecule. So we've established that as well. Now let's talk about some of the contributions that some scientists have made towards atom structure. Don't forget that topic of today is atomic structure and bonding. So let's consider some contributions of some scientists towards this aspect of chemistry. The first person I will talk about today is John Dalton. And is known to be the father of the modern atomic theory because he was the one that postulated the atomic theory. He postulated the atomic theory and is known to be the father of modern atomic theory. This theory would be going through some of them. They've been modified due to more discovery and more experiment and observations and conclusions from those experiments. So let's run through some of the theories of Dalton's, right? Atomic Dalton's theory. First, he said matter can never be created. No, let's start off with atom is the smallest indivisible particle of an element. Atom is the indivisible particle of an element, and this was valid for some time. And after a while, the discovery of proton, neutron, and electron, which we know as the subparticles of atom, nullified this theory. Protons, neutrons, and electrons. Discovery of these subparticles nullified this theory. We know what protons are. Protons are positively charged subparticle. Neutrons are neutral. That means they don't carry any charge. And electrons are negatively charged subparticle. So this has also been nullified. He also said matter can neither be created nor destroyed. Neither be created nor destroyed. This also was valid for a period of time. But as chemistry evolved, radiation came up, radioactivity, and then we discovered radioactive elements. They undergo radiation, and in the process, emission of radiation occurs. In the process of radioactivity, there's emission of radiation, and new elements can be created. Some radioactive elements would be your thorium, your uranium, your polonium. Those are part of the carbon-14 also is an example of a radioactive element. And when radioactivity occurs, it can be creation and destruction of elements. So radioactivity nullified this. Another, let me clean the board. He also said that atoms of the same element are alike in all aspects and they are different from atoms of different elements. Atoms of the same element different from atoms of other elements. But isotopy negated this. Isotopy, we know isotopy. Isotopy is a phenomenon whereby atoms of the same element have the same atomic number but different mass number, and this is due to what? Difference in neutron number. Difference in neutron number. So this was also negated. The last one I'll be talking about is where he said atoms of different elements combine in simple whole number ratio. Atoms of different elements combine in simple whole number ratio. Yes, this is true for inorganic compounds. But when we go to organic chemistry, we're talking about proteins, we're talking about carbohydrates. Those are large, giant molecules. This is not valid because you can see some giant molecules in organic chemistry. So this is valid for inorganic compounds. Organic compounds, no. No. And so we've talked about John Dalton. Let's consider another scientist, and that would be J.J. Thomson. So let's consider J.J. Thomson. J.J. Thomson. J.J. Thomson performed the cathode ray experiment. Cathode ray experiment. And based off of his findings from this experiment, his observation, and what he concluded was that an atom contains tiny negatively charged particle. Atoms contain tiny negatively charged particles. And he called those negatively charged particles as electrons. So, the discovery of electrons is credited to J.J. Thomson because he performed this experiment and came about this conclusion. So the discovery of electrons is actually accredited to J.J. Thomson, and he made a model. That model is called plumb bobbin model. Plumb bobbin model. Now let's consider another scientist. Let's consider Rutherford. Okay, so Rutherford. Rutherford performed the gold foil experiment. Gold foil experiment. He performed the gold foil experiment where he used alpha particles, bombarded alpha particles, and on gold foil, on a thin gold foil, and he noticed that some of the alpha particles passed through and some were deflected back. And the conclusion he made from that experiment was that the nucleus is positively charged and it contains the neutron and the protons. And negative charged particles orbit around the nucleus of an atom. So let me say it again. So that means the nucleus contains the neutron. The nucleus contains the neutron and the proton, right? The nucleus contains the neutron and the proton. And he said electrons orbit around it. The electrons orbit around it. So this would be the orbit. These are the electrons. This is the nucleus, and inside the nucleus you have the proton and the neutron. The discovery of proton is accredited to Rutherford rather. The discovery of proton is accredited to Rutherford. So we now know for two. We know for electrons, J.J. Thomson. We know for proton, Rutherford, and the last one is neutron. The discovery of neutron is accredited to a scientist known as James Chadwick. So this is James Chadwick, this is Rutherford, and this is J.J. Thomson. And so the last scientist to be talking about now is Niels Bohr. So now let's talk about Niels Bohr. Please can you mute your mic? Please can you mute your mic? Please can you mute your? Thank you. Okay. So Niels Bohr talked about the atomic structure model. Niels Bohr talked about the atomic structure model. And according to him, there is a nucleus. And yes, I'm listening. Atomic what? That's what is on the board. All right. Okay, so according to Niels Bohr, there is a nucleus and electrons rotate around it in a circular motion. Electrons rotate around it in a circular motion. So let's do it like this. Okay. And so this is the nucleus. Let's take this to be the proton. Let's take this to be the electron. No, the neutron rather. The neutron. And this would be the electron. Now, I'm listening. That's what is on the board. Okay, so it said there is a nucleus which is positively charged, and in the nucleus you have the proton and the neutron, and electrons orbit around it in a circular motion. So this will be the electrons, this will be the nucleus, and this will be taken as the shell. We're good with that, right? Okay, so now we've talked about some contributions, that of J.J. Thomson, Rutherford, Neil Bohr, and John Dalton. I think we're good with that. Let's move on to something else. You actually need to settle down. Calm down, settle down if you do. I'm sorry. I'm sorry. Can I continue? What do you want me to do now? What do you want me to do? What do you want exactly so that you'll be in class? What do you want? Just the diagram. Okay, so by the end of class, can you remind me? We have a lot to cover. So by the end of class, I will withdraw the diagram for you. Is that fine? Thank you. Now let's consider some atoms and the periodic table. This is the periodic table chart, and this is the modern periodic table. There used to be a periodic table before this. I would explain that as well. But this is the modern periodic table. Now let's consider a cell. I'm sure you can see this serial. Can you see this? If you can't see clearly, but can you see this? All right, thank you. So this is more like a magnified and enlarged version of each of them. And so I will redraw this. So that's the CE. And up we have 58. Down over here we have 104.